Okay, so welcome back. We're just going to do a couple of starters to make sure that you still are sharp, and then we'll move on. So these are my blocks, and remember that the red one is worth 2, the orange one is worth 3. These are all blocks that represent prime numbers, because we're going to use prime factorization to work out a few things. That one's 5, this one's 7, this one is 11, and remember the purple one was X. Okay, so what I'd like you to do now, and this shouldn't take you more than a couple of minutes, is to work out what the value of that number is, given that I told you what each block was worth, and then make that number using blocks, and then split the blocks into 2 groups to find all the fact pairs, like I did in a previous video. I'm going to give you maybe 2 minutes to do that, and slide 3 will show you a video of what you should have done. Okay, so this is 22557, so the number is 700. The first factor pair is 1 and 700. The next factor pair is 2 on the left hand side and 350. Then you've got 4 and 175. And then you've got 5 and 140. And you've got 7 and 100. And then you've got 10 and 70. And then you've got 14 and 50. And you've got 20 and 35. And you've got 25 and 28. I think that's all of them. Okay, so I'm going to give you a moment to think about what this term is. You've got a red, an orange, and 2 purples. Brilliant. You should have found that that was 6x squared, because we've got 2 purples, so that's x squared. Can you do me a favour? Can you all get your blocks and make the same 6x squared for me? Okay, and now I would like you to try and find all the factor pairs of 6x squared. greatest common factor of both of these is. I'm basically asking you, what's the largest number of blocks that you can pull out of both of them that is in both this term and this term. So you can pull out a red from both of them because they both contain a red. You can't pull out an orange from both of them. You can't pull out a yellow from both of them. And you can pull out a purple from both of them. You can't pull out two purples because the second one doesn't have two purples. So if you pull out a red and a purple, then I think your greatest common factor, that can no extent spared by me erasing my markings super quickly, is that, which is 2x. And why is that useful? Well, it's useful when you have to factor things, so let me show you what I mean. Okay, so we're going to do exactly the same question, but we're going to write them next to each other. So we know previously that this is 2x squared, and this is 30x. Okay, let's assume that we're adding these two terms. Okay, well, factoring is asking you what can you take out of this term and this term. So it's a bit like the greatest common factor. Okay, well, we looked and we know that the thing that you can take out of both of them is 2x. Can you see that from here and from here I can take a red and a purple, so that's 2x. Now if I take a red and a purple out of the first one, that leaves me with a purple from here. And if I take a red and a purple out of the second term, that leaves me with an orange and a yellow. So by magic, what this does is it means that I've got 2x outside and I've got x plus 3 times 5 is 15, not 6, is it? Sorry about that. So in order to factor 2x squared plus 30x, we pull out what we can see is the same from both expressions. We write that outside the parentheses with the bracket, and whatever's left is what's inside the bracket. And that's pretty good, don't you? So now I'd like you to try and factor the following expressions by building them as blocks and then picking out what's common from both of them. So let's try something like this. 18x minus 15. Question 1. Question 2 can be 24x cubed plus 40x. Let's have, I don't know, 50 minus 15x squared. Question 4. 12x squared y plus 20x y squared. Now this one's difficult because I haven't given you a block for y, but I wonder if you could use a different colour that you're not using to represent y.